All right, so 2021, determine the remainder when f of x is divided by x minus 1. So we'll have f of x over x minus 1 is equal to f of 1, which is equal to a into 1 cubed plus 7 into 1 squared minus 7 into 1 minus 3. So the numbers could add up. I'll get a plus 7 minus 7 is 0, and a minus 3. This is going to be our remainder. Now we used the remainder theorem for this. So I have to quote the remainder theorem. I see Dylan coming in here. So I'll recall, if any polynomial f of x is divided by x minus a, the remainder is f of a. That's the remainder. If f of a is equal to 0, then x minus a is a factor of f of x. This is the factor part. I anticipate using the factor theorem at some point in this question because this question will be based on remainder and factor theorem. So part 2. If the remainder when this is divided by x plus 3 is equal to the remainder determined in part 1, find the value of a. So we didn't use the factor theorem, but that's okay. We still write it down. So I'm going to have f of x divided by x plus 3 is equal to f of minus 3, which is a into minus 3 cubed plus 7 into minus 3 squared minus 7 into minus 3 minus 3. This is equal to, jump on my calculator, I go have 7 by 9, 63. This could be a plus here, right? Plus 21 minus 3. I get a minus 3 cubed going to be minus 27. So I'll get minus 27a plus 81. Now the question said that both of these remainders are equal. So I'm going to let a minus 3 be equal to minus 27a plus 81. Move it around. I'll get a plus 27a is equal to 81 plus 3. I'll get 28a is equal to 84. And a is equal to 84 divided by 21. Going to give my what? Sorry, 84 divided by 28. That look like 3. A is equal to 3. Bam shot. Easy peasy. 1a looking like it done. Consider the function g of x is equal to x squared plus m plus 4x plus 4m is equal to 0, which has equal and real and equal roots. So I know a thing about real and equal roots. For real and equal roots, the discriminant is greater than 0. So one time I'm going to say b squared for equal roots, for real and equal roots, b squared minus 4ac for equal roots is going to be equal to 0. For real and distinct, that is when you're going to have it being less than 0. Greater than 0, sorry. For real and equal, so now we're going to have x squared plus m plus 4x plus 4m is equal to 0. Use the discriminant of the given equation to determine the values of m. You may use the grid provided to assist you. We are going to use no grid. A is 1, B is m plus 4, and C is 4m. B squared going to be m plus 4 squared minus 4a c is equal to 0. I'll get m squared plus 4 2s are 8 m plus 16 take away 16m is equal to 0. I'll get m squared minus 8m plus 16 is equal to 0. Half of 8 is 4. This is a perfect square. All right. Let me go ahead and factorize it normally. I'm going to get factors of 16 that will add to give me minus 8. That is minus 4 and minus 4. Minus 4m plus 16 is equal to 0. I'll get m into m minus 4 minus 4 into m minus 4 is equal to 0. I'll get m minus 4 into m minus 4 is equal to 0. And I get m is equal to 4 only. So they say that are the values for m, which will kind of give me a false sense that I have more than one value in my solution. But based on my working, I only have one value. I don't think I make a mistake anywhere. All right, so the working for this could have been a little bit questionable because of the instructions in the question, because they say values. All right, graph, we are gonna bother. We know how to do calculations for it, so we good to go. Part C. All right, express. So we want to complete the square. So I'll have 2x squared plus 8x minus 10. 2 into, well, I'm going to do it step by step, right? Put all the x terms in the bracket. 2x squared plus 8x. Leave a big space, minus 10. Factorize all the 2. X squared plus 4x. And I add in half the coefficient of x. Half of 4 is 2. Squared minus 10. And I'll have to take away 2 multiplied by 2 squared. The middle is now a perfect square. I'll get 2 into x plus 2 squared minus 10. 2 to the 4. Here, 2 to the 4. 4 to the 8. So there is minus 10 minus 8 is minus 18. It is of the form a into x plus b squared plus c, where a is 2, b is 2, and c is minus 18. Now let's say what the minimum value of h of x. So the minimum value occurs at. Now, what I'm going to do, I'm going to write down what we usually accustomed to seeing, right? A into x plus h squared plus k, right? So the minimum value occurs at k. In this case, k is the same thing as c. So minimum value occurs at c, which is equal to minus 18. So what the minimum value of the entire function. And determine the value of x. So the value of x for which h of x is a min occurs at x is equal to minus h. In this case, h corresponds to b, so x is equal to minus b. X will be equal to minus 2. We good to go. Right, and that's it for number 1. Number 2, given that so by so, find the value of a. So log of 6 plus root 12 to base 2 minus log of 3 plus root a to base 2 is equal to log 10. Whenever you use a law of logs, recall it. So I'll recall. Also, if they didn't give you a base on the log, you could safely assume it's base 10. So this here is base 10. So log 10 to base 10 is 1. So what we go deal with that just now. So I see now take a subtraction of 2 separate logs. If I recall, log of m to base b minus log of n to base b is equal to log of m over n to base b. Also, log of a to base a is equal to 1. So now we're going to have log of 6 plus root 12 divided by 3 plus root a. Yeah. 3 plus root a to base 2 is equal to 1. Now, in my same recall line, I'm going to learn how to go from log to indice. So I'll have log of if log of a to base b is equal to c, I can turn this into an indice. This is b to the power c is equal to a. I'm going to do that down here. 2 to the power 1 is equal to 6 plus root 12 over 3 plus root a. Cross multiply. 2 into 3 plus root a is equal to 6 plus root 12. Nothing wrong if you use a calculator for these things, yeah? 6, divide both sides by 2. I get 3 plus root a is equal to 6 plus root 12 divided by 2. And leave it like that. Divided by 2. And then I go take away 3 on both sides. Hola, Kulura. So far, so good. I'm going to try and figure out what this is on my calculator. Because to get a by itself, I have to square both sides, right? So I'm just going to work out what this is on my calculator. Pull up my calculator. 6 plus root 12. That's my numerator divided by 2. And my denominator, take away 3. And I'm squaring this. 3. So a is equal to all of this all squared. A is equal to 3. So you don't have to go and fight up and look to rationalize, because I know when you see it right, gauge up with a root on the denominator, you're thinking rationalization. Okay, A is 3. Determine a set of values for which this is less than 0. So if I have 2 minus x divided by 4x minus 9 is less than 0, the chain of command here is multiply by the square denominator. So I'll multiply by 4x minus 9 all squared. And I will end up with 2 minus x into 4x minus 9 is less than 0. I will do this. I'm going to get, I'm going to let this, I will let 2 minus x into 4x minus 9 be equal to 0 and solve. 2 minus x is 0. I'll get x is equal to 2. Or 4x minus 9 is 0. X is equal to 9 over 4. This is 2 1/4. Now, time to get my solutions. This here, all I want to know is what is the coefficient of x squared. So the x by the x gives me a negative. So minus x by 4x gives me minus 4x squared. So this curve looks like this. I'm going to put in my roots, which is what I just calculated. This is 2, and this is 9 over 4. I want to know where this is less than 0, which is under the x-axis. It's going to be here and here, which is the union of the two sets of values. So now I can say x is such that x is less than 2. I do not have an equal to sign attached into my question, so I do not put in an equal to sign attached in my answer. X is such that x is greater than 9 over 4. And we're good to go. All right, so next one. Alice deposited $4,000 into her new savings bank account, which pays interest at 8% per annum. The bank's compounded interest, represented by the geometric progression. Okay, so they give us a formula. Cool. where A is the amount of money accumulated after T years. R is the percentage rate of interest, and T is a positive integer. Determine the number of years it will take Alice's money to at least triple. So if she deposited 4,000 into her savings account by the principal, right? So P is equal to 4,000. The rate is 8%. And triple 4,000. So how to put this in statements, boy? I go let. We want to know how much years it will take for Alice's money to at least triple. That going to be 12,000. That could be the amount, right? For it to be triple, 4,000 by 3 is 12,000. And I'm going to just fill out the rest of my formula. Going to be 4,000 multiplied by 1 plus 8 over 100, which is 0.1208 raised to the power of t. I need to calculate t. Divide both sides by 4,000. I get 3 is equal to 1 plus 0.08 to the power t. I'll take ln on both sides. Take ln on both sides. I like to take ln. I'll get ln 3 is ln 1 plus 1.08 to the power t. I'll recall log of a to the power c to base b works both ways. It's c log of a to base b. So ln 3 is t ln 1.08. T is equal to ln 3 divided by ln of 1.08, which is equal to, jump on the calculator again, ln 3, ln 3 divided by ln 1.08, 14.27 or 14.3 years. Now, this is the amount of years it will take for her money to at least triple. Anything less than 14.3 years, the money is not going to triple. So if they want the number of years without having like a fraction of a year, then we're going to have to round it up. Number of years for her money to at least triple, going to be 15. And that's it for number 2. Not bad. Number 3. The coordinates for the center of a circle is 2, 1. And the coordinates for a point on its circumference is 3, 3. Determine the equation of the circle in the form of that. Okay, so I have a point on the circle and I have the center of the circle, which means I can go ahead and calculate the radius. Sorry. So I can say that now we can be a little bit smart here. I have the center. And the center of a circle will allow us to write down the formula for the circle, which could be x take away 2 squared plus y take away 1 squared is equal to r squared. Or cool with that. This is the equation of the circle. Now, granted that 3, 3 is a point on the circle, I'm going to let x be equal to 3 and y be equal to 3. This can make stuff a little bit, well, a lot bit easier. I'm going to get 3 minus 2 squared plus 3 minus 1 squared is equal to r squared. 3 minus 2 is 1. 1 squared is 1. Plus 3 minus 1 squared. 3 minus 1, is 2. 2 2s are 4. Is r squared. So 5 is equal to r squared. And r is equal to root 5. Now, Since I have r squared on this side, I don't need to calculate what r is. Now I go have x minus 2 squared plus y minus 1 squared is equal to 5. It's just to expand. X squared minus 4x plus 4 plus y squared minus 2x plus 1 is equal to 5. So what the x squared and the y squared together? Sorry, this is not supposed to be 2x, it's supposed to be 2y. Then the what the ax, which is going to be 4x. Then the y minus 2y. 4 plus 1 is 5. And when I move the 5, that will be 0. Plus 0 is equal to 0. So C in this case is 0. So I'm going to say, no, the set I wanted in the form plus ax, right? So what we're going to do here, I mean, yeah, we can leave it like that, right? Is of the form x squared plus y squared plus ax plus by plus c is equal to 0, where a is minus 4, b is minus 2, and c is equal to 0. Cool. All right, part 2. The circle intersects the y and x axes at 3 points. Determine the coordinates of the 3 points of intersection. Okay, so I can say that all for part 2. The circle cuts the y-axis at x is equal to 0. So I go let, I using this form of the equation, right? Let 0 minus 2 squared plus y minus 1 squared is equal to 5. It's going to be 4 plus y minus 1 squared is equal to 5. Move it across. Y minus 1 squared is equal to 5. Take away 4 is 1. Square root both sides. Y minus 1 going to be plus or minus 1. And y is going to be equal to plus or minus 1 plus 1. So 1 going to be y is equal to 1 plus 1, which is 2. And y going to be minus 1 plus 1, which is equal to 0. So I get 2 points of intersection here. So, yeah. So therefore, 2 points of intersection are when x is 0, y is 2. When x is 0, y is 0. And I can say now, the circle cuts the x-axis at y is equal to 0. So I will let x minus 2 squared plus 0 minus 1 squared is equal to 5. X minus 2 squared plus 1 is equal to 5. So x minus 2 squared is equal to 4. X minus 2 is equal to plus or minus 2. So I get x is equal to plus or minus 2 plus 2. X is equal to 2 plus 2, which is 4. And x is equal to minus 2 plus 2, which is 0. So therefore, 2 points of intersection are, and you'll realize 1 point repeats, right? When x is 4, y is 0. And when x is 0, y is 0. So therefore, 3 points of intersection are 0, 0, 0, 2, and 4, 0. Determine the equation of the tangent to the circle at the point 3, 3. So we go ahead and get the gradient. Lord Jesus. So I'm going to let the tangent at 3, 3 be L1. Let the tangent at 3, 3 be L1. Whatever next way we gotta do this, but I don't want to show that form as yet. So let me go through it. So I'm gonna get the gradient, or let the tangent be L at 3, 3 at, I'm gonna put at A, B, L1, and below this, I'm going to say, let A be 3, 3. Good. So now we're gonna get a gradient of the gradient of, I'm gonna put OA, where O is equal to, I'm gonna let O be the center. O is 2, 1. Gradient of OA is going to be y2 minus y1 over x2 minus x1, which is equal to x1 y1, x2 y2, y2 minus y1 over x2 minus x1. 1 minus 3 is minus 2. 2 minus 3 is minus 1, which is equal to 2. Now, how to recall two laws here for equation of tangents. A tangent meets a radius at 90 degrees at the point of contact, as well as the product of gradient of perpendicular lines is minus 1. Now I can say that the gradient of L1 is going to be minus a half. And I already have the reason right above here. Equation of L1 using the point 3, 3. This is my x1 and my y1 is going to be y minus y1 is m into x minus x1. Y minus 3 is minus a half into x minus 3. So I'll get y is equal to minus 1/2 x plus 3 over 2 plus 3. 3 over 2 plus 3. I go in and play hero. I have my calculator. 3 over 2 plus 3. 9 over 2. Y is equal to minus 1/2 x plus 9 over 2. Let me just double check and see if they wanted it in a particular form. They didn't want it in no particular form, so I can go ahead and say is of the form y is equal to mx plus c, where m is my gradient, which is equal to minus a half, and c is the y-intercept, which is equal to 9 over 2. Cool. Part B. The position vectors of 2 points P and Q relative to a fixed origin O are given by that. Determine the unit vector in the direction of PQ, giving your answer in its simplest form. Alright, so I'm going to do my working here, right? Utilize the space as much as you can. So I'm going to let the unit vector in the, actually, let me see if I can do this by, I'm going to take some lines. I want some lines. Put some lines inside of here. Nice. Nice. Smart. So let the unit vector in the direction of PQ be U hat. U hat is going to be equal to the vector PQ divided by the size of the vector PQ. So first, let's get PQ. So PQ is going to be PO plus OQ, which is equal to negative OP plus OQ, which is equal to negative OP, which is 2 minus 3, plus OQ, which is minus 4, 1. So we can go ahead and add these two things together to get minus 2 minus 4 is minus 6. And this becomes plus 3, right? That becomes plus 3. 3 plus 1 is 4, minus 6, 4. The size of PQ now is going to be the square root of the I component squared plus the j component squared, which is going to be minus 6 squared plus 4 squared. We're going to leave it in search, right? That is 36 plus 16. Again, we jump in on my calculator. Nothing wrong with that. Root 52. And we could break this down in surge, right? So root 52 could be what? 4 by what? Let me check and see. Let me check and see divided by 16 if we get anything. Nah. So 52 divided by 4 is 13. So that root 4 root 13. Root 4 is 2. So this is 2 root 13. So U hat is now going to be, what I'm going to do, I'm going to change my vector PQ in IJ format, which is going to be minus 6I plus 4J divided by 2 root 13. I'm going to put each part over the 2 root 13. Minus 6 over 2 root 13 I plus 4 over 2 root 13 j. The 2 could go into this 3 times. The 2 could go into this 2 times. So U hat is equal to, now if I want I could leave it in IJ format, but granted that they gave me vectors in column vector format, I'll give them back the answer in column vector format. I just changed to my IJ format to facilitate a little easier canceling and working out. So in my column vector format, the top entry is going to be minus 3 over root 13, and the bottom is going to be 2 over root 13. And this is in its simplest form. Part C, given that m is that and m is acute, determine the value of tan 2m. Okay, it's been a while since we had a tan double angle formula coming. So these types of questions as always line up to be a right angle triangle. So I'll recall that cosine theta is equal to adjacent over hypotenuse. So I'm going to draw my right angle triangle. Bam shot. If this is the angle M, cos M is 24 and 25, which is adjacent over hypotenuse. So I'll calculate my opposite. Hypotenuse squared is equal to opposite squared plus adjacent squared. The hypotenuse is 25. 25 squared is equal to, I don't know what the opposite is, so I'll leave that as opposite squared plus 24 squared. So the opposite is going to be equal to, we add math students, 25 squared take away 24 squared. 25 squared take away 24 squared is 49. So the opposite is going to be 7. If you want to overdo it, you could say plus or minus 7, and it's going to be plus 7 because we're dealing with length, and length is always greater than 0, but you don't have to. If you want to, no problem. So the opposite is 7. So now I'll recall also that tan 2m is equal to 2 tan m over 1 minus tan squared m. So tan 2m is equal to 2. Oh, before I do this opposite downstairs there, let me get what tan of m is now. So tan m is equal to opposite over adjacent, which is going to be 7 over 24. So this is 2 into 7 over 24 divided by 1 minus 7 over 24 squared. So tan of 2m is equal to, let me look at my calculator yet again. 1 take away 7 over 24 squared. And it is, that going to be the 2 go cancel with the 24 to get 7 over 12. So 7 over 12 divided by whatever answer I had just now on my calculator, I get 356 over 527. That looks weird. 336 over how much? 527. Looking kind of weird. I don't think I make any mistakes. But even if our angle looks real weird, that is okay. Right? That's a-okay. For 4 marks, I would at least give her 5 marks for this question. This question deserves a little 5 marks. Alright, and that's it for number 3. Alright, so number 4, differentiate this with respect to x. So I'll have to let y equal sine x plus cos 4x and dy dx. Sine changes to cosine. Cosine changes to negative sine. And I must multiply by the differential of the angle. Easy 2 marks. Easiest 2 marks of your life. Alright, differentiate again. We go let y be equal to 2x cubed plus 2 over 2x plus 1. 2 into x cubed plus 1 right now. Is of the form u over v, where u is equal to 2x cubed plus 2 and du dx is equal to 6x squared and v is equal to 2x plus 1. dv dx is just 2. dy dx is equal to v du dx minus u dv dx all over v squared. For 3 marks, I'll give about 4 marks for this. Even 5 marks I will give for this. This is my quotient rule. So I'm guessing how they would have calculated this. Just by the way, right? It's just going off topic a little bit. 1 mark, 1 mark, and I get 1 mark for getting the simplified version of your answer. V du dx minus u dv dx all over v squared. Let's simplify it up. I'll get 6x cubed, 12x cubed plus 6x squared. Take away 2 to the 4x cubed plus 2 all over 2x plus 1 squared. I can simplify again. 12 minus 4 is 8x cubed plus 6x squared plus 2 all over 2x plus 1 squared. I wouldn't go any further into simplifying this. Whether I have to use some remainder factor theorem or long division to do this, I wouldn't go any further. I wouldn't even bother to factorize the top. I'll just leave it as it is. Right. Using the principles of differentiation to compute the stationary value of the function, or use the principle of differentiation to compute. Okay, cool. They want the stationary value of the function. They don't want the stationary points. Now, a stationary point requires a x and a y. A stationary value just requires the y alone. Cool? So I'm going to say if y is equal to x squared minus 4x plus 2, the y dx is going to be 2x minus 4. So we say at a stationary point, the y dx is equal to 0. So I will let 2x minus 4 equals 0. 2x is equal to 4. X is equal to 2. When x is equal to 2, y is equal to 2 squared minus 4 into 2 plus 2. 2 to the 4. 4 take away 8 is minus 4. Minus 4 plus 2 is minus 2. All cool with that? So this here is my stationary value. And you can put it here is the stationary value. If you want to dot your T's and cross your I's, you don't have to, right? The last line in your working should reflect your answer. You don't have to. Right, part C, a motorist starts from a point X, travels due north to a point Y at a constant speed. He states that the average speed, tra-la-la-la. All right, so this gauging up to be a 60 meters due north at a constant speed of 4 meters per second. Stays there for 25 seconds. Velocity time graph. Let's go. So, question. How do I know it's a velocity time graph? They want us to calculate the average speed for the journey. Average speed is total distance traveled over total time taken. Now, we have one distance traveled here, 60 meters. Let me read the question properly, right? A motorist starts from a point X and travels 60 meters due north to a point Y. So before I dive into my first instinct here is velocity time graph, and that is without reading the whole question. Let me read the whole question. A motorist starts from a point X, travels 60 meters due north to a point Y. So X to Y, 60 meters at 4 meters per second. Okay. He stays at Y for 25 seconds. So at Y, stays at Y for 25 seconds. I don't know if this could help me while writing on here, just checking out something, right? And travels at a constant speed of 10 meters per second for 100 meters due south to a point Z. So from Y to Z is 100 meters at 10 meters per second. The average speed for the whole journey. So the total, we have the whole distance, right? The whole distance he traveled going to be 60 plus 100, which is 160. Total distance traveled is 160. Total time taken. We could get it time from the first one. Time is equal to distance over speed. We could get it time for the second one. Time is equal to distance over speed. So time from x to y gonna be distance over speed, which is distance is speed by time. Distance is speed by time. So time is distance over speed, yes. So the distance is 60 and the speed is 4. 60 divided by 4 is what? Let me jump on the calculator. That is going to be 15 seconds. And the time from y to z is going to be distance over speed again, which is 100 over 10, which is 10 seconds. So I can actually calculate my average velocity. Sorry, average speed. Ooh. Is equal to total distance traveled divided by total time taken. Which is equal to total distance traveled is going to be 100 plus the 60 divided by total time taken. It's going to be 15 plus 25 plus 10. Check it out. 160 divided by 15 plus 25 plus 10. 3.2 meters per second. That is my average speed. Now my average velocity, same formula, total distance traveled over total time taken, but this time we have to take into consideration, instead of distance, it could be displacement. And if he travels 100 meters, 60 meters north, and then he travels 100 meters south, velocity will take into consideration displacement. So the displacement is just going to be the 60, take away the 100, divided by whatever time it is. The time going to remain the same. 15 plus 25 plus 10. $60 minus 100 is negative 40. I will just put 40. I will put any minus sign afterwards. 40 divided by 15 plus 25 plus 10. I get 0.8, which is 4/5. So I had to put the minus sign. Minus 4/5 meters per second. That's going to be his average velocity for the whole journey. Now that I mean the man reversing. All right. Yeah, it does. Oh well. That's it for number 4. All right, so negative velocity just means he's going in the opposite direction. Number 5. Determine the following integrals, giving each answer in its simplest form. So number 1, I could do the working right underneath the question, right? The integral of 2x squared plus 3x going to be 2x cubed over 3 plus 3x squared over 2 plus c, and we need to say where c is a constant. Now, A says that these two parts are connected, so I cannot use C as my constant downstairs here. So 2 sine 3x, when I differentiate cosine, I get negative sine. So if I integrate sine, I'll get negative cosine. So the sine changes to negative cosine. I'll get minus 2 cosine 3x, and I have to divide by the differential of the angle, which is 3 plus k, where k is a constant. Right? Easy, easy marks. All right, part B, using an integration method, calculate the area of the region in the first quadrant under the graph y is equal to sine 3x. In the first quadrant. So in the first quadrant for the graph y is equal to sine 3x, ideally they should have given us the limit, at least an upper limit, because 3 sine x, that graph goes on forever. So in the first quadrant, let me just illustrate it a little bit here. In the first quadrant, sine x. In the first quadrant, all this happened in the first quadrant. All of these humps happen in the first quadrant. So if I want the area in the first quadrant, it could be the area between 0 and, this is going to be pi. Then it's going to be between pi on 2 and 3 pi. Sorry, it could be between 2 pi and 3 pi. Then it could be between 4 pi and 5 pi and so on. So they should have given us a little indication where they want me to stop. Nevertheless, I know what they mean. They wanted it for the first bell. So lining up, I'm going to have the integral. Because we know how the sine curves look, I know the upper limit going to be pi, the lower limit going to be 0, and I'm going to get 3 sine x dx. Sine changes to cosine, so I'm going to get minus 3 cosine x between the limits pi and 0, which is going to be minus 3 cosine of pi, take away minus 3 cosine of 0. Now put this in radians and calculate it on the calculator. Exactly as you see it here, 0.18. So you don't get mixed up with no minus signs. So open bracket. I'm changing degrees in radians first. Minus 3 cosine pi. Take away, open bracket, minus 3 cosine 0. Close bracket, 1, 2. No, 1 close bracket. Good. Equals 6. 6 square units, because they told us, hey, this is a integration. A particle starting from rest travels in a straight line with an acceleration a, given by a is equal to t squared. All right, a is equal to t squared. And I'll remember my zva. So I know how to integrate some business here, right? Determine the velocity of the particle. I knew it. V is equal to the integral of a with respect to t. V is equal to the integral of t squared with respect to t. V is equal to t cubed on 3 plus c, where c is a constant. The question said the particle starts from rest. At rest, v is 0 and t is 0. So I get 0 is equal to 0 cubed over 3 plus c. I get c is 0. So therefore, v is equal to t cubed over 3, or 1/3 t cubed. Calculate the displacement s of the particle in the interval of time t is equal to 0 to t is equal to 2. So we had to get s. Now s is equal to the integral of v with respect to t. Remember, they gave us conditions at rest, which is, this case, it could be s is 0 and t is 0. S is equal to the integral of t cubed on 3. And I'm going to fix how this integral looks. I can pull the 1/3 on the outside, the integral of t cubed dt. S is equal to a third t to the power 4 over 4 plus k, where k is a constant. This is a third multiplied by a quarter, which is 1/12. So I could put it now as t to the power 4 over 12 plus k. We say at rest, s is 0 and t is 0. And you can now put therefore k will also be 0. So s is equal to t to the power 4 over 12. Now, this is where, yes, the integrating using the limits could have worked, but we had to be sure, because we're not sure if the particle moving forward and backward, forward and backward. So I'm gonna draw my table at time, well, t is equal to, and then I have s. So when t is 0, s is gonna be 0. When t is 1, s is gonna be 1 over 12. When t is 2, s is gonna be 2 to the power 4 is what? I'm going to my calculator. 2 to the power 4 divided by 12 is 4 over 3. So right through the particle moving forward, 4 over 3. So from t is equal to 0 to t is equal to 2 seconds, the particle traveled from here to here, from here to here, he traveled 1/12 meters. And then from here to here, he will travel 4 over 3, take away 1/12. And when we add up both of them, we're going to get the 4 over 3. Right? So he traveled 4 over 3 meters. Cool. That's it for number 5. Right, so 6 part A. 2 fair tetrahedral dice with faces numbered 1, 2, 3, 4 are rolled. The numbers obtained on the turned down face of dice are noted. It doesn't matter if it was turned down or turned up. It doesn't matter. So don't let the turn down confuse you, right? Create a sample space diagram. So sample space going to have 1, 2, 3, and 4. This is for dice 1. And 1, 2, 3, and 4. This is my outcomes for dice 2. So creating my sample space diagram. Right, my line's little bender is okay. I could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. Alright, so this is going to be very self-explanatory now. 2 and 3, 2 and 4. These are all the outcomes, right? 3, 1. I'll put the 4, 1 here one time. 3, 2, 4, 2, 3, 3, 4, 3, 3, 4, and 4, 4. So I have 16. Total number of possible outcomes is 16, right? Total number of possible outcomes is equal to 16. Always write down the total number of possible outcomes when all you're posed with a sample space diagram. All right. Using your sample space or otherwise, sample space is the way to go, yes? So I'm bringing this down because we're going to use this. So we're going to walk with this wherever we're going to determine the probability of obtaining a 4 on both dice. That's going to be 1 out of the 16. So if you want, you could name the event, but I'm not going to let the event be so by so. I will just say the probability of obtaining a 4 on both dice is this is the only outcome here, which is 1 out of the 16. Next, the probability of obtaining a 4 on at least one dice. At least is 1 and more. So we have 1, 2, 3, 4, 5, 6, 7. 7 out of 16. And the probability of obtaining a 4. Obtaining a 4 on exactly one dice. That's going to be 6 out of 16 because this is the only case where we have a 4 on the 2 dice. So this is exactly one dice, one dice, one dice, one dice, one dice, one dice. Because the 4 was rolled on the second dice here, and the 4 was rolled on the first dice here. So that's going to be 6 out of 16, which is equal to 3 out of 8. Show that obtaining a 4 on both dice are independent events. So this is going to be, for independent events, the probability of A intersect B is the probability of A multiplied by the probability of B. So obtaining a 4 on both dice going to be the probability of a 4 on dice 1, 4 on dice 1, and a 4 on dice 2. A 4 on dice 1 and or intersect a 4 on dice 2. This is 1 out of 16. If the events are independent, the probability of 4 on dice 1 multiplied by the probability of a 4 on dice 2 supposed to be the same thing. The probability of getting a 4 on dice 1 is going to be, let me say this is dice 1 and this is dice 2, right? Dice 1 will go be the second number. Obtaining a 4 on dice 1, obtaining a 4 on both dice, yeah. Obtaining a 4 on dice 1 going to be 1, 2, 3, 4 out of 16, which is a quarter. I'll leave it as 4 out of 16, multiplied by obtaining a 4 on dice 2 will be 1, 2, 3, 4 out of 16. 4 out of 16 by 4 out of 16 dies a quarter by a quarter, which is 1 out of 16. So I can say, therefore, obtaining a 4 on both dice are independent. Obtaining a 4 on both dice are independent. Now, it would have been a lot easier to follow this working if I named the events. For example, if I say, let the probability of getting a 4 on dice 1 be A, and the probability of getting a 4, the event that a 4 on dice 1 is A, and getting a 4 on dice 1 is B, instead of having 4 on dice 1 intersect 4 on dice 2, I'll have the probability of A intersect B. For independent events, probability of A intersect B is equal to the probability of A multiplied by the probability of B. We already have the probability of A intersect B. There's a 4 on the first dice and a 4 on the second dice. We get that from the sample space diagram. The second line, the probability of a 4 on the first dice, we calculated that. That could be the probability of A multiplied by the probability of B. So listing the events might have the write-up looking a little bit nicer than what I have here. Determine the probability of obtaining a 4 on both dice given. So let me name the events, right? Watch how easier it is to name the events. So let the event, let X be the event obtaining a 4 on both dice. Given that the 4 was, and let Y be the event. Oh, I spelled obtaining wrong on the first one. My apologies. Obtaining a 4 on at least one dice. What I want is the probability of x, given that y has already occurred. This is the probability of x intersect y divided by the probability of y. Now, x intersect y going to be getting a 4 on both dice and obtaining a 4 on at least one dice. Determine the probability of obtaining a 4 on both dice, given that 4 on both dice and a 4 on one dice. So the 4 on both dice going to be this here, intersect 4 on at least one dice. So one dice going to be all of these here. So the intersection just going to be the 4 and the 4, which going to be the 1 out of 16. Over obtaining a 4 on at least one dice, 7 over 16. That is 1 over 16 multiplied by 16 over 7, which is going to give us 1 out of 7. So in the beginning, if I would have named the events instead of doing this, it might have made the question a little bit easier to understand. At least in terms of the write-up. All right, box plot. Oh, Lord Jesus. It this way. Make it bigger. All right, so calculate the median score. So I go and had a guesstimate here, right? The median score looking like, this looking like 10, 10.2468, no. This is halfway between 10 and 12, so this is gonna be 11 here. So this looking like a day. It's looking like 11. The range going to be the highest minus the lowest. 20 take away 4, which is 16. Semi-interquartile range going to be the Q3 take away Q1. So Q3 looking like I don't know, 17? Nah, it can't be that. It had to be 17. So we want IQR or SIQR. Semi-interquartile range is a half Q3 minus Q1. From what I reading off here, Q3 looking like 17. And Q1, I want to say 7. 17 minus 7 is 10. Half of 10 is 5. Ogoroi. Ogoroi. All right, good, yeah. Yeah. Put that here. Bring it across here. All right, comment on the shape of the distribution of the scores. All right, so let me get some numbers coming into here, right? Q3 minus Q2 is 17 take away 11, which is 6. That is the distance from here to here. Q2 minus Q1, 11 take away 7, which is 4. Now, granted that how Q3 minus Q2 is greater than Q2 minus Q1, this distribution is positively skewed. Oh God. If Q3 minus Q2 was less than, then it's going to be negatively skewed. So this is calculations. You could also look at the distribution and calculate it as well, right? A student wants to determine the mean score. State one reason why it will be impossible to determine the mean score. You can't get a mean score from this because you don't have One, you don't have the sum of all the values, and two, you don't have the you have the number of students. You have 30 students. The total score possible. So you have 30 pieces of data you have. So you actually have n, but you don't have the sum of all of the scores. So that's why I cannot calculate the mean. What additional piece of information will be needed? You need the sum of all the scores. Given that the sum of the 30 scores, they give you the sum of the 30 scores, is that, and the sum of the squares of the scores is that, calculate the standard deviation. So standard deviation, we could get a mean from this. X bar, the sum of the scores is 354 divided by 30. Oh, let me put it as this. Sigma f over sigma x over n, which is equal to 354 over 30. Jump on my calculator to get the mean, because we need the mean to calculate standard deviation. 11.8. Standard deviation, sigma, is equal to the square root of sigma x minus x bar all squared over n. The sum of the squares of the scores. Oh, so we're going to use a different, let me use the next formula for this. It could be sigma x squared over n. Take away the sum, well, x bar all squared. So the sum of the squares of all the scores is this here. Oops. Nice. Which is equal to, the sum of all the squares is 4994 divided by the n is 30. Take away the mean squared and the square root of all of this. So again, let's jump on the calculator. Four 994 over 30. Take away 11.8 squared. Square root of this, 5.2. To say any amount of decimal places? They didn't say. 5.22. 5.22 to 2 decimal places. And that's it for number